Hello friends, welcome in my channel. Myself Ganesh Borhade. Today learn integrator and differentiator using OpAmp, that is the IC741. The IC741 is used as a amplifier. Also it can be used for the arithmetic operation like addition, subtraction, multiplication, division. Same, the IC741 can be used as a integrator and differentiator. Hello guys, please like, share and subscribe my channel. Then first, OpAmp used as an integrator. It is basically an inverting integrator in which R1 is the input resistor and CF is the feedback capacitor. This is the inverting amplifier, means apply the input signal to the inverting terminal of the op-amp and non-inverting terminal is connected to the ground. This is the active integrator, means connect the resistor R1 in series with the input resistance, input voltage and the capacitor connected in the feedback path. Therefore, this is the active integrator, means when apply the input signal to the inverting terminal of the op-amp, then output is the integration of the input signal, means when apply the sine wave, the output is the cosine. When apply the square wave, the output is the triangular wave, and when apply the triangular wave, output is the sine wave, means the output is the integration of the input signal. Therefore, what is the equation for the integrator? That is the output voltage equation. V0 or the V out is equal to minus 1 upon R1 CF integration limit 0 to t V in dt, right? This is the equation for the integrator. This equation indicates that output voltage is directly proportional to the negative integral of the input voltage. Why there is a minus sign? Because input applied to the inverting terminal of the op-amp. Then to calculate the output voltage, first the charge on the capacitor. This capacitor is connected in the feedback path. Therefore, calculate the what is the charge on the capacitor. The charge on the capacitor is Q, and Q is equal to capacitance into voltage across the capacitor. Therefore, CF into Vc. The current flowing through the capacitor is, what is the current flowing through the capacitor? This input current I1 and IF is the same, and therefore what is the current flowing through the capacitor? Therefore, the current flowing through the capacitor IF is equal to, the current is the rate of change of capacitance. Therefore, IF is equal to dq by dt. Then put the value of q in this equation. Therefore, the equation become d by dt into cf into vc. Then what is the equation? IF is equal to cf. Cf is the constant. Therefore, take outside cf dvc by dt. This is the equation number 1. This is the current flowing through the capacitor, that is the IF, CF dVc by dt. Then where Vc means the what is the voltage across the capacitor, is voltage across the capacitor and is given by Vc is the V2, this V2 minus V0. This is the equation number 2. Then put the value of Vc. Then what is the input current? Input current is the I1 or the In, which is equal to the feedback current, that is the IF. Therefore, what is the input current? Current is always voltage divided by resistance. Therefore, is equal to V in minus V2. This voltage V in minus V2 divided by R1. This is the equation number 3. Then put the equation 2 and equation 3 in equation 1. Okay. Then put the value of IF. IF is the V in minus V2 divided by R1, right? Then CF by dt. And what is the value of Vc? That is the V2 minus V0. Okay. Then due to the virtual short concept, what is the virtual short concept? If one terminal is connected to the ground, then due to the virtual short concept, the another terminal also at the ground potential. Therefore, V1 is equal to V2 is equal to 0 volt, right? Therefore, put the value of V2 in this equation, put the value of V2. V2 is the 0. Therefore, equation become Vn by R1 is equal to this minus sign minus Cf dV0 by dt, because the V2 is the 0. Therefore, minus Cf dV0 by dt, right? Then calculate the equation for the output voltage. Therefore, dV0 take one side, then equation become dV0 is equal to this minus sign minus 1 upon R1 Cf minus 1 upon R1 Cf V in dt. This is the equation number 4. Then take the integration of the equation number 4, right? Therefore, integration of dV0 is equal to integration of 0 to t minus 1 upon R1 Cf V in dt plus C. Therefore, integration and derivative get cancelled. Therefore, V0 is equal to minus 1 upon R1 Cf is the constant. Therefore, take outside. 1 upon R1 Cf integration limit 0 to t V in dt plus C. C is the integration constant. This equation indicate that this is the output voltage equation for the integrator using OpAmp. This equation indicate that output is the directly proportional to the integration of the input voltage, where R1 Cf are constant and C is the integration constant. Okay. Then next point is the OpAmp used as an differentiator, means the output is the derivative of the input signal. This is the equation, or this is the circuit of the OpAmp can be used as an differentiator. Only what is the difference between integrator and differentiator? Only interchange the position of resistor and capacitor, means apply the input signal to the capacitor, means capacitor is connected in series, and in feedback path there is a RF and non-inverting terminal is connected to the 0. Therefore, output voltage is equal to minus. Why minus sign? Because input applied to the inverting terminal, minus RF into C dV in by dt. Then how to get this equation? First calculate I in. I in is the input current. I in is equal to IF. Therefore, I in is equal to, what is the input current? Minus V out divided by RF, right? Or the IF is also same. IF is equal to, current is always voltage divided by resistance. Therefore, I in or IF is equal to minus. Why minus sign? Because the output is again applied to the inverting terminal. Therefore, minus V out divided by RF. The charge on the capacitor. What is the charge? Charge is always capacitance into voltage. Thus, the rate of change of this charge is dq by dt is equal to C is the constant dV in by dt. But dq by dt is the capacitor current, that is I in. I in is the dq by dt. Current is always changing charge with respect to time. Therefore, what is the input current? I in is the dq by dt. Then put I in is equal to C dV in by dt. This is the I in, and C dV in by dt is equal to IF. Current, because I in is equal to IF. Then put the value of IF in this equation. Therefore, minus V out divided by RF is equal to C dV in by dt, from which we have an ideal voltage output for the OpAmp differentiator is given as V out is equal to, then the output voltage is equal to minus this minus sign minus RF into C dV in by dt. This is the equation for the differentiator. This equation indicates that output is directly proportional to the derivative of the input signal, and RF and C are the constant. Okay, these are the waveform of the differentiator. Means when apply the square wave, the output is the spikes, positive and negative spikes. When apply the triangular wave, then output is the rectangular wave. When apply the sine wave, then output is the cosine wave. Means the output is the derivative of the input signal. Thank you guys. Please subscribe, like, share and give the comment in the comment box. Thank you.